What is the best way to match amplifier output impedance? Imagine trying to push water through a pipe. If the pipe is too narrow or too wide, the flow isn't smooth. The same idea applies to electrical signals in amplifiers. Matching the output impedance of an amplifier to the load or next stage is key to getting the best performance. But how do engineers do this effectively? That's what we're here to uncover. First, understanding impedance matching means making sure the amplifier's output impedance and the load impedance are either equal or conjugate matched. When they are conjugate matched, the resistive parts are the same, and the reactive parts are opposite in sign. This setup allows maximum power transfer and reduces signal reflections. For low-frequency audio or simple analog circuits, matching is often done with resistors because it's straightforward. You just add a resistor in series or parallel to match the load. In high-frequency or radio frequency applications, things get more complex. Because at these frequencies, impedance isn't just resistive but reactive too, involving inductors and capacitors. Engineers use reactive matching networks made of coils and capacitors to tune the impedance precisely. These networks can be designed as L networks, pi networks, or T networks, depending on the specific needs. They are tuned to work over a certain frequency or bandwidth and are very effective at minimizing signal loss and distortion. Transformers are another popular tool. They work by changing the turns ratio to match the load impedance to the amplifier's output impedance. This method is lossless and works well for audio power amplifiers and radio transmitters. Transformers also provide galvanic isolation, which can be helpful in preventing ground loops and noise. For even more precise matching, especially at high frequencies, engineers use transmission line techniques. Quarter-wave transformers or stub tuners are placed along the line to transform impedances. These methods are common in RF systems where signals are very sensitive to reflections and losses. In multi-stage amplifier systems, impedance matching between stages is vital. It helps reduce power loss and prevents distortion. Often, coupling networks that use resistors, capacitors, or transformers are used to match the output of one stage to the input of the next. This ensures the entire system runs smoothly and efficiently. Choosing the best method depends on your application. For low frequencies and broadband signals, simple resistor or transformer matching works well. For high frequencies and narrow bandwidths, reactive networks or transmission line techniques are better. Synthetic impedance matching, which uses feedback to simulate a desired impedance, can also be useful when you want to avoid power losses from resistors. In summary, the most effective way to match amplifier output impedance is to select the method that best balances efficiency, signal integrity, and complexity for your specific needs. Whether you use resistors, transformers, reactive networks, or transmission lines, understanding your load and frequency range guides you to the right choice. Proper impedance matching ensures your amplifier delivers the best possible performance with minimal signal loss or distortion.